So we are given that E and F are two independent events. This is again question from 2024 CBSE exam. E and F are given to be two independent events. And probability of E bar. Now E bar is, so this is the universal set, so U. If this is E, whatever is inside, whatever is outside is E bar. So it's a opposite, not E, basically not E, that wherever E is does not occur. So probability of A plus probability of E bar is probability of U, which is universal, so it is 1. So probability of E bar is given to be 0.6, so probability of E can be calculated from there, which will be 1 minus 0.6, this will be 0.4, and then probability of E union F, this is given to be 0.6. Now probability of E union, and we have to find out two things. We have to find out probability of F and probability of E bar union F bar. So probability of E union F, this is a standard equation, probability of E plus probability of F minus probability of E intersection of F. Now this thing, probability of E intersection F, this is because E and F are independent, so when E and F are independent, this will be equal to probability of E into probability of F. So the two probabilities are independent of each other, so their intersection is when both of them occur together. This is equal to multiplication of those two separately. And then say probability of F, will have to assume, say probability of F is X. Now probability of E intersection F will be, probability of E is, we found out already, 0.4. Probability of F is X, so 0.4x. So we put these values into the equation. Probability of E union F is 0.6, probability of E is 0.4, plus probability of F we have assumed to be X, minus E intersection F is 0.4x. This 0.4 goes to the other side, this will be 0.2, and X minus 0.4x is 0.6x. Now X will be equal to 0.2 divided by 0.6, which will be 1 by 3. So probability of F is equal to 1 by 3. Now let's just look at what we have. So probability of F is there, probability of F bar, which is wherever F is not there, which will be 2 by 3, 1 minus probability of F, 1 minus 1 by 3, and probability of E and E bar we already have. E is 0.6, 0.4, and probability of E bar we already have 0.6. Then we are required to find probability of E bar union F bar, which will be probability of E bar plus probability of F bar plus minus probability of E bar intersection F bar. Now this thing again can be written as probability of E bar into probability of F bar. Why? Because E and F are independent events of their own, in their own. So E bar and F bar are also independent events of their own. So let's put these values. E bar is 0.6, 0.6 can be written as 3 by 5. You open it up and you'll see probability of f bar is 2 by 3 minus probability of e bar is 3 by 5 into this is 2 by 3. Wait, I did something wrong somewhere. So this will be 2 by 5. Let's take an LCM, it will be 15. This gets multiplied by 3, 9, this by 5 which is 10, this by 3 which is 6. 19 minus 6 is 30. 13 by 15. So probability of E bar union F bar is equal to 13 by 15. So this is the second part of the answer. First part of answer was this one, probability of F is 1 by